This conference will now be recorded.
Okay, so welcome everyone. This is Roshan. I'll be the instructor for this workshop on understanding performance architecting in AWS Cloud. So before we get started, this workshop would be for around 45 minutes. Okay, and we can ask any questions. It's going to be interactive session, so you can ask me any questions. You can ask me to stop, and we can discuss about it. And yeah, and it's going to be I'm going to just demonstrating about the AWS services, which plays a very important role in performance architecting, in performance of any application, right? So, okay, before we get started, let me introduce myself. My name is Roshan. I have a 17 years of experience, 16 to 17 years experience in IT. I started my career as a Java developer, and then I moved into Java performance engineering, and then I moved into SRE role from last 6 years. Right, I've been into automation using various DevOps tools, uh, Terraform, Ansible, used shell scripting and Python scripting for automation. I'm Kubernetes expert, and I'm currently like from last 6 years I'm completely into containerized applications. So I'm working in those space. I currently associated with one of the biggest retail giant in the world as a principal SRE consultant. So that's background about me. Just quickly, could you like introduce yourself? I just want to understand. I believe most of the folks that we have joined this forum are related to performance engineering or SRE, right? Is that right? Quickly, could you put that in the chat, your good domain and years experience, so that I understand and we'll take this workshop in a better way. If just in the chat, domain, years experience, that would be enough. Good for me. Perfect. Rosini, performance testing engineering, 7 years. Great. Vinay, PT, 4 years. Perfect. Sure. So my audience looks like from the something to do with the performance, right? Everybody. Okay. Perfect. KCC PT with 2.8. Good. Okay. So you are at the right place because we're gonna talk about performance in the cloud. We'll talk about in AWS how it plays important role, and what as a performance engineer what we should be concerned about, what we should learn, right? So we'll talk about these things, so it will give you a good perspective of things that you're already involved, right? And how what to do in the future to make your career better and for the better career aspirations, right? So this is what we're going to discuss. Okay, so see, we know everything nowadays is happening. If you look at the architecture, most of the architecture that is being developed, and if you look at the infrastructure also, so there are two common things. What are the two common things? That the deployment is happening, the infrastructure is on the cloud, AWS, Azure, GCP. I have been fortunate enough to work with 3 to 4 cloud service provider in my career. I have worked with AWS, Azure, and GCP, and OCI. So I can talk about these four. And if you know one, it's all good, right? So works all the cloud. They have the common objective, the features or the use case is common, right? Getting the servers, getting storage, right? So those things. So managing users, managing security, so these are the common use cases of using cloud. So if you know one cloud service provider, you're good. So it's mandatory, it's must for all of us to know cloud. That's because every deployment is happening in the cloud. Earlier it was not the case. Earlier the deployments were happening in the on premise. So see, the on premise and cloud, how does it differ? Uh, just to give you a brief, you some of you may know, or if you would have attended my session some time back, you would know that. But let me just talk, take few minutes to talk from very basics from scratch, okay, so that we all are on the same page. So when we talk about cloud and on-prem, the difference, right? This very important. We need to understand the difference because that's where the understanding comes. See, as a performance engineer, we need to be very like logical, rational in our thought process, right? So and it starts from here. See, in on-premise, we have the servers, right? See, the data center is common. Either you go on-premise or you use cloud. The data center is common. The infrastructure is common where you deploy application, right? So if I just show you a data center, this is how a typical data center looks like. Consider a multi-story building in the outskirts of a city, multi-story building. So think of a building like this, multi-story building. Think of a multi-story building in the outskirts of a city somewhere, and with all the rooms and halls, big halls, full of these kind of servers. These kind of servers. This is a typical data center. Okay, that's how a data center looks like. These kind of servers. These data centers are full of these kind of servers. So this is what a data center looks like. So now the question is, who owns it? The company where you work, if they own this kind of a data center, that kind of facility, so that is on premise. That's simple definition. That's on premise, we call it. So see, it's a very huge cost investment involved, right? Somebody has to purchase the land, construct the building, the infrastructure, procure all the servers, operating system, security, different kinds of regulations, right? A lot of, and these servers cannot run out of power. So separate electrical grid, multiple power sources, multiple network switches, multiple internet service providers. So multiple of everything because these servers cannot run out of power. It has to be 24 by 7. Your laptop is also a server. If it runs 24 by 7, you can deploy your application, right? So, but if you need more servers, so you need to go towards the data center, right? So, if you own this kind of a data center or the company where you work, they own. So that's like on-premise. You can say that you're working on on-premise, but not everybody can afford this. We know that, right? Because huge billions of dollars goes into this investment. So, and if you have a business idea like Swiggy, Ola, Uber, you have some business idea, new business, and you need servers. You have the code, you can recruit few developers, let's say quality assurance engineers, performance engineers. Let's say you build one software, but now you deploy that, and the application may scale like Flipkart, right? It can grow, the user base can grow, so you need more servers. So, and you cannot set up this kind of data center. So, what do? We go to the cloud. So, somebody else had set up this kind of data centers like AWS, Amazon Web Services, or Azure, Microsoft, or Google. They have set up these kind of data centers, and it's like a business for them. So they would give you all the servers for on the rent basis, like how we stay in a rented apartment, right? As long as we keep paying the rent, we can enjoy the services, right? But the moment we stop paying, again, we cannot be allowed to continue to stay, right? So that's how it is. So as long as we are paying the bill of cloud, depending on how many servers we are using, right, depends on the scale of application I may have few users or more users, depends, right? So cloud works in the pay as you go model. So more you use, more you have to pay. If you're using more servers, you have to pay more, right? So that's where we have these services. So we everybody, if you want to use cloud, every cloud, AWS, Azure, GCP, they have this beautiful console. We all need to create an account in the cloud. We call it, so it's a free. Every cloud service provider wants you to learn how to use it. So every cloud service provider, they offer some free tier, some freebies for you to learn, so that you can learn, and if you like it, you can continue, and they would earn money out of it, right? That's how their business model. So For example, we are talking about AWS here. So let's say you want to deploy your infrastructure in AWS. So where will you deploy? The first question is, where will you deploy the AWS? Which so there are so many data centers they have. If you look at the infrastructure, if I just show you the infrastructure landscape, what they have, AWS, they have 102 availability zones. So when I say availability zones, it's like a data center. Okay, you can just understand like that. 102 such data centers, which I was showing you right earlier in this, they have set up kind of this kind of infrastructure. 102 infrastructure they have. So think about how much investment they have done. 102 AZs, we call it, availability zones, and they are available in 32 launch regions. In India, they are available in Mumbai and Hyderabad. You can come here and see this. In Mumbai and Hyderabad they have, and they have presence all across the globe. As you can see here, the green dots is available. Is that they have the regions. So they are also in San Paulo, and they are also in North America. They are also in Africa, in Cape Town. They are also in Australia. They are in New Zealand. They are in Europe. They are into, so they're like multiple. They are you, and they are growing. So if you would have come to this page some 2 years back, you would have got a different number. You would have got a different number. But now they are growing, and you can see this. The red ones are coming soon. So they are also planning to come in Auckland, in New Zealand, and sing the red ones. So red ones in Malaysia, and then you have Thailand, and then you have Germany, and they also have it in this Canada way. So they are planning also. It's gonna grow. So it's for them, it's a business. So let's talk about AWS. So how AWS Cloud was born. So I believe all of us knows about the founder of Amazon.com, right? Jeff Bezos, right? So the guy was setting up on-premise for his application Amazon.com. He was setting up on-premise his own data center. And in the process of doing that, he realized, so whatever he is doing can be leveraged to others as well. And that's where the idea of AWS came to his mind, and it's become so global now. So he has two AWS, Amazon.com as well as AWS. So they are two business entity and he has, and growing quite well. So that's how the AWS came into existence. And it's all about the services, right? So let's say they have the infrastructure. We understood that. That's good. Why do they have infrastructure, and what is the importance for us? So let's say if you are living in India, let's say for example, you're living in New Delhi, capital, let's say, or any place in India, and you have a business idea, let's say for European customer or for Australian customer, let's say. So you have the code, you have recruited 10, 15, 20 developers, and let's say you have some startup kind of a thing, and you have developed the application, or you have to deploy that. So the question is, which region would you deploy that? So that's the question number one on the performance. That will determine your user experience, whether your user is going to have good experience or a bad experience or average experience, because the latency would be different. If you choose the region, the data center, that will decide the user experience. So let's say you are thinking about an application, a software that is gonna be good for European customers, let's say people living in Europe. So ideally, what do you think? Where would you deploy your code? Where will you get the server? Which availability zone you will be using it to deploy your code? What do you think? It's gonna be in India, it's gonna be in Australia, it's gonna be in US, or it's gonna be in Europe? I'm asking a question. Yeah.
Yeah, obviously Europe.
Europe, right? Absolutely, right? No doubt about it. So we need to understand about this infrastructure. That then only we could make this decision, right? Because if the customer is Europe, they are hitting some website, could be abcxyg.com. And if the server is located far from them, far from the customer, so the network packet has to travel far, and the latency would be more. Think about if if your server is in let's say Australia, and some customer in Europe, let's say some customer is Ireland, is hitting a website. That is the website, the server is in Australia, so the network packet has to travel all the way to Australia and then it has to go back. Then only the user will get the response. So the network packet has to travel a long way. So the latency will increase, but you don't want to do that, right? So to better decision would be have an infrastructure in Europe, somewhere nearby, right? Could be so use these availability zones. Could use the Spain region, or we could use the Ireland region, right? That would be better, or London region, right? We have the infrastructure deployed there. So that's point number one. That's very important to understand where should we deploy the code. And we get this option. So if you go to AWS console, so how we gonna deploy things in this region? So what AWS has done, or every cloud service provider they have done, they have this beautiful console, management console. They have this. All you need to do is create an account in AWS, which is free. So you can go to aws.amazon.com. This is a simple website, and you can create an account. Simple website, aws.amazon.com, right? You can go here and you can create an account, create an AWS account. It's a free tier. It's not going to be chargeable, right? There are a lot of things in the free tier. So and you would get this kind of console once you create an account and you log in. You get this kind of console, and then you need servers, right? You have the code with you. You have the developers working, but you need the server. So we have services here that we need to use. So services like EC2. EC2 is a service. Everything in the cloud that you want to use is through the services, all the use case. So here the use case is server. I need the server, right? You more number of servers because I have a more user load. Depends on my requirement again. So I need servers. So what would I do? I'll go to the management console and I'll go to EC2 and I'll get the server. EC2 stands for Elastic Compute Cloud. In AWS, if you need the server, you need to come here and get some servers. Go to instances, get some servers, and you can deploy your application. But that's not about it, right? It's not about deploying the servers. We need to talk about auto scaling also. That's very important because the auto scaling plays a very important role in cost optimization as well as better scalability. It can handle load in a better way. So auto scaling is very important from the cloud perspective. This is not possible in on-premise. I'll give you a simple example. Okay, I have a simple example here. Okay, I have a simple example. Okay, I'm going to just talk about this. I already have it handy with me. So think about that you have an application between 7 a.m. to 10 a.m. Think about your Swiggy or Zomato kind of application. 7 a.m. to 10 a.m. You have 10,000 users. When you are looking into the production and you're thinking there are 10,000 users accessing the application, and to support 10,000 users you have done the performance testing to understand that what is the ratio between the server and the users. You have to do the testing, right? You can start small, you can start with two servers, and then you can understand how many load it can handle, TPS or users actions, right? It can handle, and then you can take a call that for these many servers, how many for these many users, how many servers are required, or these many TPS, how many servers are required. So you can take a call based on your small testing, and then you can extrapolate that, And I'm giving you a number that between 7 a.m. to 10 a.m. you have these many users accessing the application, and you need 100 servers. For 10 a.m. to 1 p.m. you have 7,000 users and you need 70 servers. So similarly, for 1 p.m. to 4 p.m. you have 20,000, you need 200 servers. Then for 50 servers, 500 servers, right? And let's say between you need 20 servers. So think about it. So you have this kind of, you are observing this kind of requirement. Now I'm going to ask you a simple question, and I would like to see who all can answer. Simple, very simple question. If you are in on-prem, if you have an on-prem infrastructure, forget about cloud right now. If you are in on-prem, how many servers you need to procure? You have to purchase, because you have to purchase in on-premise. There is no other option. So to support the entire day workload, think about it. Look at the distribution here. To support the entire day workload, how many servers you would require? You can put in the chat. Right? Simple question, or you can unmute yourself. That's fine. Yeah. Okay. Think about it. Right. 7 a.m. to 10 a.m. there are so many user load, total user load. To support these many, you need these many servers. Between 6 to 11 p.m. you have these many users load, 50,000 users, and you need these many servers. You have the distribution in front of you. How many total servers you need to procure? Total server you have to procure. Minimum, max, forget about it, Sanjay, right? You have to purchase it.
500, 507.
500. 500. Yes, it's 500, right? No doubt about it, right? I don't know, Vinay, you have mentioned 100. I don't know what you thinking. Because see, during 6 p.m. to 11 p.m., if I have only 100 servers, Vinay, think about your performance. How it's going to be? It's going to be worse, right? You're going to find a lot of errors, exceptions, 5xx, 4xx, 2xx, I don't know, 2xx would be very little status code. You're going to have a lot of errors, exceptions. Because during this time, you need so many users accessing the application and you need these many servers. So totally, guys, we have to purchase 500 servers in on-premise. Yes, no doubt. And most of you have answered that, right? But think about in the cloud. Do we do we purchase the servers in the cloud? No, we don't. Somebody else has set up. They have infinite servers, but we pay a bill, right? Cost is the ultimate thing. The cost is the most important thing. Every decision, cost plays a very, very important thing in every decision, in the cloud particularly, because it's pay as you go. More you use, more you will pay. Less you use, less you will pay. Simple. So do you think you need to run 500 servers 24 by 7 in the cloud?
No, actually, it will be need based.
Right. So correct, Sanjay. Absolutely. How about others? Others, could we understand that we don't need to run 500 servers all the time in the cloud? Do we understand this? It's a very simple thing, guys. Very basics. Don't think you don't know cloud. I'm not talking about cloud. I'm talking about normal thing. Do we need to run 24 by 7, 500 servers all the time? Asking this question from everybody. Please put in the chat or unmute yourself. I need everybody to respond. Absolutely no. Okay. 500 servers are required only for 5 hours, as I've highlighted, 6 p.m. to 11 p.m. 5 hours. For 5 hours of maximum load, that's where that's when I'm getting the peak load. I don't need to run same number of servers all the time in the cloud. We have a concept of auto scaling. We can provision specific number of servers at a specific time, or we can auto scale servers based on some criteria like CPU. Think about it. During 7 a.m. to 10 a.m., you have 100 servers, all good. All the thousands 10,000 users accessing your application are happy. No performance degradation, everybody is happy. User experience is great. But slowly, after 10 a.m., you have less users. So again, with 100 servers, with 100 servers, 7,000 users can easily manage, absolutely manage, no doubt about it, right? But do you require 100 servers for these one for 3 hours? Do you really require 100 servers? Why are you paying more? Because you are using more. You have asked for me, so it's like a asking using 100 houses, 100 flats, right? You have to pay rent, so you have to pay charges. So we if we have an option of scaling down here, if we have an option of reducing the number of servers, do you think that will be better during this time? Listen, absolutely yes, because that will reduce the cost. So we use auto scaling in the cloud, guys, to save the cost. See, cost and performance, right? See, both goes hand in hand. If you're thinking about performance and if you're not thinking about cost, you're not thinking thoroughly. Okay, keep this in mind. This is a very important thing. We have to both think about both, right? I don't want you to compromise your performance, but at the same time, the company would expect you to achieve the performance with the least cost. How do you do that? That's your skill. That's the skill they're expecting. How would you design it? So auto scaling is must thing in the cloud. If not, we're gonna have 500 servers. If you're paying, you're gonna pay a lot of amount. So if you have auto scaling configured, we do have an auto scaling option in the cloud. Like if you go to EC2, in the EC2 itself, we have auto scaling group. We have the load balancer group. I can configure this auto scaling and based on some criteria like CPU utilization. CPU is one of the very important criteria. Based on CPU is more or less. So I'm going to give you a simple example. At 10 a.m. Right now, let's say between 7 a.m. to 10 a.m. you have CPU utilization of, I'm giving you a number, 60%. All good. With 100 servers. Now tell me one thing. With 100 servers for 7,000 users, your CPU utilization will go high or less. During this time, 10 a.m. to 1 p.m., with the same number of servers, you're gonna serve less number of users. Your CPU utilization will go to high or less.
Less.
Less, absolutely less. I have got more servers now. So if I put a condition that scale down my servers if CPU utilization goes above a particular threshold is less than 30% or 25% or 20%, 20% for 10 minutes, for 10 samples, for 10 samples in 10 minutes. If I put this kind of condition, do you think I'll be able to reduce the cost? If I put such a condition and I'll put if this condition meets, scale down my server by 2 servers or 3 servers, I'll go step by step. Do you think if I do that, I'll be able to reduce the cost and I'll not be able to, and I'm not compromising on the performance? Do we agree on this, everybody?
Yeah.
Absolutely right. Same thing. Now I have got 70 servers. Let's say after one by 1 p.m. Let's say I got 70 servers. Now my users are increasing. So obviously my CPU utilization gonna suit up. I will also put one more condition. If CPU utilization is more than 60% or 50% for this long, scale up, scale up more than 50% for 5 samples in 5 minutes. So it will understand that the requirement, and I'll give a, for this kind of condition, I'll mention scale out. So my server should scale up, and I'll be able to manage the traffic load without any performance degradation. So auto scaling is very, very important. So that's point number one. So auto scaling, load balancer. See, now when the servers are increasing, so it has to be done with the load balancer. Okay, it has to be done through load balancers because servers are increasing, decreasing, and you gonna hit one load balancer. So auto scaling is very important, and you have to manage the load balancer also. Right, so both, so very important. Now, other services. What all the other services that can help you in AWS? So this kind of monitoring in AWS, this kind of conditions you put in the CloudWatch, right? So the service name where you set auto scaling and load balancer is EC2. Okay, so sub service, I'm going to give you the service name, EC2 service name. Service name is EC2. But under EC2 only you get the servers, right? As you can see here, I'm in the EC2 Elastic Compute Cloud, and I can configure auto scaling group and other things. Now, second thing, in cloud we have a concept of managed service. Very important, very good. So these managed, what are these main managed services? So AWS, right? AWS gives you some sort of guarantee. So there are a lot of managed services in AWS. Okay, I'll come to the managed services. Let me talk about the second service first, which does this monitoring part. I was talking about, right, that I need to put some conditions, some alarms, right? So that service name is CloudWatch. So very important metric. So CloudWatch is the monitoring solution. So if I create a server, let's say I'm going to show you how to create a server. Let's say I'm going to launch instance, and I'm going to show you the CloudWatch. CloudWatch is the monitoring solution, and in the CloudWatch itself, you can put some conditions, alarms. You can create some alarms, and based on those conditions, auto scaling can trigger. Right. So I'm creating a server. Okay, server one. I'm giving a name. So let's say I'm going to create Ubuntu operating system. I can select Microsoft, Windows, or Red Hat, or Amazon Linux. I have multiple. I'm selecting Ubuntu, right? Instance type is the how many cores and RAM I have in the EC2 instance. It's like configuring your laptop. Creating an EC2 instance is same as configuring your laptop, right? So how many cores RAM you require. So you can mention. Uh, just to be in free tier eligible, you can select T2.micro. You will not incur any cost, but you have the option of going up to a 8 cores, 16 cores, 32 cores. You can see 5.4x large if that has 16 vCPU, 16 cores and 32 GB RAM. Right? So cost would increase. 72 cores, 144 GB RAM. I can get that also. But just to be in the free tier eligible, I'm going to select T2.micro, 1 vCPU, 1 GB RAM. Some key pair for some authentication. I need a key pair. Okay. Some network settings. I'm getting a server. This is the disk. Okay. So launch instance. I have provisioned a server, and that server is having 1 vCPU, 1 GB RAM in AWS, and I have selected in Mumbai region. As I told you, I have got 32 regions. I can select anywhere. I can be in the remotest part of the globe. If I have a laptop and internet connectivity, I can do wonders. I can create a server in US, deploy my application in US if I have the cloud internet connectivity in my laptop. That's all. I can do wonders in the remotest part, and that's what cloud gives you, that flexibility, that opportunity, that option. Right, so this is the server we have, and it's 1 vCPU, 1 GB RAM. So it's not that much resource we don't have. And you can see the CloudWatch is always there, monitoring section. So this monitoring section that you can see here, CPU, let the time happen. I just created it, so wait for some time, 5-10 minutes, and it will show up all those CPU, all the graphs would start coming up, and these graphs are coming from the CloudWatch, one of the service monitoring service in AWS. I can connect to this server. I can install a web server. I can do a lot of things in this server. This is a server, right? That's where I'm using this cloud for. That's about the server, right? So we have this EC2, and we have CloudWatch. As I showed you, we have CloudWatch as one of the another service. Everything is through service in cloud. So CloudWatch is a monitoring solution. I can create some alarms here. As you can see, alarms, when to scale out, when to scale down, right? These kind of things. When when scale out, scale in, I can do all those things, right? In the CloudWatch, I can get all the logs, metrics. So CloudWatch is the for performance engineers. Was one of the very important services because that's talk about the monitoring. And performance engineers monitoring is so important. We need to understand the server logs. We need to go over the metrics, CPU, memory utilization, and all those things. Now, the third thing what we have is managed services. We have got a lot of managed services in AWS. Managed. Managed services are those services where AWS guarantees a lot of performance commitments. AWS manages, first of all, I would say, AWS and guarantees significant performance numbers. Right? A lot of things. We have services. So you need to know cloud, okay, first of all. Then only we can discuss about it. So, for example, I'll just give you, we have S3, one of the storage service. The entire Netflix that you watch, I hope everybody uses or knows about Netflix, Amazon Prime Videos, the entire Hotstar, all those contents that we watch is hosted in S3. S3 stands for Simple Storage Service. AWS has a lot of options. If you store some content here, AWS has a lot of options in making the streaming better, making the performance better. We have, let's say, if you're storing things, S3 is the service, okay, again. So we have S3 storage service. In the storage service, we have S3, simple storage service. So entire Netflix that we watch is stored here. Netflix is one of the greatest customer of AWS. So Hotstar, Amazon Prime Video is a no-brainer where they are from the same company, right? So this is the bucket we need to create, and we have a lot of options that if something content you store, and if a customer is watching, wants to access the objects, the content, we have functionality like S3 transfer acceleration that increases the performance immensely. Transfer acceleration that will accelerate the content, the way a speed the content is being received by the customers. That's one very important thing we have. We have other kinds of storage managed services where AWS guarantees its availability. Availability is also important, like load balancer. I was showing you in under EC2 load balancer. Load balancer is also AWS managed service. So AWS guarantees its availability. AWS tells no need to worry about its scalability. Let the traffic come as much as it wants. I'm going to charge you some amount, but I will not let the performance go down or load balancer go down. So AWS has a lot of managed services. Based on that, we get a lot of good support from AWS. If you are in Kubernetes, let's say you're working on a containerized applications, we have service like EKS, Elastic Kubernetes Service, where Kubernetes entire thing, first of all, you need to know Kubernetes, okay? Then only you will understand what I'm telling. For the entire Kubernetes cluster, AWS takes the guarantees and for its availability and it's for performance. AWS guarantees. So the infrastructure challenges are sorted. That's what I'm trying to tell you. The challenges, the infrastructure and network challenges are being sorted by AWS through these managed services. AWS takes care of those things. Infrastructure, network, and availability challenges, network latency, and availability, whether that server would be up or not. These kind of challenges are being taken care by AWS. As a user, what we need to worry about their code performance. That is same. Either you are in on-premise or in cloud, code performance you have to take care. Application performance you have to take care. If it's a Java code, we need to talk about whether the code has been written correctly or not, efficiently or not. Is code taking a lot of time? So we need to understand the how much time it is taking, response time for each transactions. We need to understand if for any issues like high CPU, we need to understand the thread dump, memory issues, heap dump, right? We need to understand memory issue again, GC log, GC algorithms. We need to talk about those things. So as a user, you need to focus on the code part because that's you have brought in. But the infrastructure, network latency, availability challenges, all these things are being taken care by AWS itself. So it's a huge, huge thing. Yes, I know. We realize this. It's a much better thing if some AWS where I'm deploying the application is taking care of all these things. What else? Right? Able to follow, guys, to some extent. I hope I'm making sense. Yes? No? Yeah, yeah, definitely. Perfect. Yeah. So we need to know cloud, okay? Then only we can discuss more about it. So the first thing that you want to do in your career, right, to do well in your career as a performance engineer, seeing yourself as a principal performance engineer or senior performance engineer, right, lead or manager, the first thing that we should all do, learn the cloud because the things are deployed in the cloud, and about the application performance, how to tune your code, database queries, SQL tuning. So that is you, and anything to do with your application, you have to take care. But apart from that, anything infra related, network related, availability related, installation related, those maintenance activity, backup activity, all those things are taken care by AWS, the cloud, right? Yeah. So, and we have services, okay, a lot of services in this. If I talk about containers, if you're working on microservices, so we have services like EKS, ECS, databases. Things are automated in the cloud. It's a managed services. All are managed services. If you require an Oracle cloud to be used, you don't need to worry about it installation. They would do that. Cloud would do that. They have RDS, relational database service. You would go there and you will create the infrastructure, the or database, and all you need to do mention in the infrastructure, how many cores, how much RAM, and they would install this for you. That's the managed service. So they have a lot of managed services. Okay. When they launched in 2007, they only launched with three services. Okay, understand this. In 2007, they launched with only three services. They launched with EC2 for the servers, S3 for the storage, and SQS, simple queue service for queue. And right now, after 15 years, 16 years, they have 200 plus services. And all they have done is taken care of the customer issues and they have helped them. They have helped them. So with every use case, customer issues, big issues, what they could think can be generalized, they have generalized this. If you're into game development, you can use this. If you're into Internet of Things, you can use this. So a lot of things are being automated, simplified by the cloud. All you need to do on the performance side is focus on the code, and everything else is being taken care by the cloud. Okay. So that's all I wanted to give you a brief, guys. So just to letting you know that please plan your career in such a way that you get to learn these things. Okay, that's must thing for you. Just an informational message for everybody, and if those are looking for the places how to get all the information in one place, right? For a performance engineers, how to get all the information that is required. So I have a course. Okay, so you can go over this link. We have a course. You can join this course. I'm going to share you the link. We have a course on SRE, performance engineering. Okay, where we have topics, all these topics that we are talking about, right? With Isa. Uh, I'm with Isa from last 4 years. I'm taking up this course, performance engineering in DevOps, and SRE course. So you can go over the content, okay, the feedbacks of the customers of my people, of my learners, and the what all things are being covered here. Cloud is covered. AWS is covered from scratch. Okay, the way we have discussed, same way, scratch. Linux. What I have realized, people not comfortable with Windows, but not good with Linux that much. Okay. And all the enterprise applications are deployed in Linux operating system. Right now, also, I created a Linux server. I'm not sure how many of us here can install a web server or log into this Linux server or no SSH also. Okay. And for SSH, we require port 22. I'm not sure how many. Most of you would know, I'm guessing. But these things are very, very basic knowledge. Okay. So we should know this. It's a Linux server, how to SSH, how to install, deploy things, what is security group in the cloud, how can I control the traffic, how can I get them some security done. So these are some basic stuff. In this course, we are talking about from very basics. So, all right, this is about the course on the cloud, and then on the Linux part, how to be comfortable with Linux. Then the SRE topics, what is SLO, SLIs, SLA, and other topics, disaster recovery, high availability, reliability, what does it mean? Monolithic and microservices architecture. What is containerization? What is Docker? What is Kubernetes? These things are must. So if you would have attended the interview, you would have realized that whatever I'm listing here is a question in is one of the questions in an interview, right? It's going to be because that's how the world is operating. It's completely into microservices, completely into containerization, Docker, Kubernetes, Jenkins, pipeline, automation. We need to know performance engineering and DevOps, right? How to gain resiliency in AWS, observability using Grafana, Prometheus, ELK stack, and CloudWatch. I just showed you. Linux monitoring. If you don't have any such commercial tools, how to use Linux server to monitor things, Linux commands, top, SAR, like mpstat, vmstat, iostat, how to understand how to interpret those things. So we're talking about Linux monitoring here, troubleshooting, Java performance engineering. So this course is full of the all these topics that you require for your next career move. I have personally designed this course, and you can go over this content. Okay, we have the batch coming in from tomorrow itself. Okay, from tomorrow we have this. We have done the demo last week. We can share the demo with you, but as you can see, we're gonna start tomorrow. Um, yeah, so you can join tomorrow. Everybody can join. You can ask the link in the group. Somebody from Isa would share. You can join tomorrow and see how things are being done. I'll talk more about the course, and you can take an informed decision what you should do in your career, right? Uh, but trust me, whatever we talked about, cloud, Linux, microservices, Docker, Kubernetes, Jenkins, observability, performance engineering, we all need to know all of those things, okay, to move in your career. And with this kind of content, I can easily 35, 30 lakhs per annum can be easily achieved. And my learners have been doing it, right? So you can go over it. So all this link. So I'm going to share this link, okay, with everybody without. Okay, I have shared the link. Please go over it, join the session tomorrow, and take an informed decision what you should do in your career. Okay, so that's all. Okay, from my side. I hope you learned something. This 45 minutes to 50 minutes was worth spending with me, right? I hope there are some takeaways for you from this session. Yeah, can I take yes from everybody?
Yes, Rasan. Can we ask
Yeah,
some question now or like?
yeah. Go ahead, Sanjay.
Looks like there's so many things to cover in this course, right?
Yeah, yeah, right.
How detailed it is going to be? Is it going to be just primarily like focused on just to get to know all this technology, or like we'll be getting in-depth
It's
knowledge on few of the
hands-on,
topics? Okay.
in depth, okay, in depth.
Mm-hmm.
And the way we are able to manage with this vast content, as you correctly mentioned, is
Mm-hmm.
separating some recorded session and live sessions. We have a
Okay.
split. So we do in two ways. So we take up 35 to 40 live hours of live sessions. So this course is
Mm-hmm.
gonna go till 2.5 months. Okay, it's not like
Okay.
15-20 days. We meet every weekends, and this
Mm-hmm.
course usually takes 2.5 months. Last batch that I've taken was started on in September. Okay, and
Okay.
completed now, and I'm starting a new batch now. And next batch is going to be in March only. March, definitely. So it is four batches, 4 to 5 batches in a year. That's what we do here. And the way
Uh-huh.
we have done it, we have split this. So we have the live sessions as well as the recorded sessions. As you can see in this link,
Right.
you would see the recorded sessions will be provided. Okay, and it's going to be my recorded sessions. Okay, for these
Okay.
topics. And wherever you don't see the recorded in the bracket, it's going to be live sessions. Okay,
Sure.
so and it's going to be
Mm-hmm.
completely detailed hands-on sessions, and that's why it's 35 hours is a significant time, right? It's a 35-40 hours significant time. So yeah, and it's going to be completely a lot of details, whatever required. Okay, it's not just on touching on the surface and talking theoretical. It's all hands-on. If I'm talking about EKS, I will demonstrate Kubernetes. I will first make you understand what is Kubernetes.
Mm-hmm.
I will create a cluster, and I will demonstrate how do you create pods, what is horizontal pod auto scaling, what is vertical auto scaling, everything about Kubernetes, all you need to require to know as a performance engineer to move in your next career move. So it's going to
Okay.
be a detailed session. Yeah.
So is it performance engineer or this is SRE? What is
See,
the job role we
this
are targeting?
we are targeting both here, okay, in this
Both.
course,
Okay.
because for performance engineering we have a recorded session for Java. See, if you want
Mm-hmm.
to do well in your Java performance engineering career, right?
Mm-hmm.
So we are not talking about Jmeter or load runner here. That I'm going to expect that you would know that. That's not part of the course. On the troubleshooting, even SRE engineers needs to troubleshoot the things in production,
Okay.
right? That's the main job of an SRE engineer. Apart from the automation activity, the the important role of an SRE engineer is troubleshoot production
Mm-hmm.
issues, right? And that's when
Okay.
the troubleshooting mindset would help. And for the performance engineering, we have this recorded, as you can see here, 8 hours of Java performance engineering self-paced. So
Okay.
it's going to be recorded session. So we are targeting both two skill sets here in this course: performance engineering and SRE in
Yes.
this course. And with automation, we will talk about Terraform, we will talk about Ansible, right? So we will
Yeah.
talk about observability. So we will talk about those things. So yeah, go over this topic link. I understand it's
Sure.
going to be
Sure.
a lot of topics,
Mm-hmm.
and yeah, it's took a lot of time for me to put all these topics together. Okay, so trust me.
Right.
So yeah, so a lot of thought process has gone into this. It can, just by looking into the topics, you would understand what to do with your career, what you should do in your career. That's this link itself is going to be a guiding thing, what to be done, what you should learn as the next topic, right?
Sure.
So go over this link, join tomorrow, and we can discuss more on it. Yeah.
Yeah, yeah, absolutely. Yeah, absolutely. So last question, or like second last question. What is the career path for SRE in your opinion? Like once you are SRE, what you do next? Like once you get few years of experience, or say like five
No,
years,
no,
10 years of experience.
you be a senior person in SRE. SRE is
Okay,
the ultimate
okay,
ultimate thing. You're gonna
okay,
be
okay,
taking
okay.
care of production. Okay, it's not one person job. I'm not sure about your
Right,
skill
right.
sets, but
Mm-hmm,
SRE, if you know, it's a production. It's a much important job. Okay,
mm-hmm,
customer P- Flipkart is, if Flipkart is available right now. If I click on this Flipkart.com, and
mm-hmm.
if I'm getting the page, it is not the developer who is responsible if something goes wrong here. It is the
Okay.
SRE who's going to take care of this in immediately
Yeah, yeah. Okay,
if
sure.
something is down. So it's going to be
Mm-hmm,
the ultimate thing. What do you
mm-hmm.
expect to be more? You would grow in that career. You can be an SRE lead, a principal SRE engineer, a manager, a director. Complete
Mm-hmm.
SRE is a complete career map in itself, because
Okay,
that's a
okay.
keeping this, see, keeping your production highly available, performing, it's a that the most important role in a company, right?
Mm-hmm. So, like once I complete this training with sincerity, right? So I will be able to clear the interview because I'm not related to
Absolutely.
SRE as of now. Yeah, as of now, I'm not related to SRE at all.
So you are working in a non-production environment, right, Sanjay? As I could
I
sense, right?
have, yeah, I have worked in production environment, but that was mostly related to databases, right? Not related to web application or anything like that, right?
I am talking about Sanjay here. You are
Mm-hmm.
somebody, you are in office, somebody is reporting. Sanjay, please join the call. We are getting 5xx code in production. Customer is getting bad response time. Please come and fix it.
No, I'm not getting those kind of calls
Correct.
or yeah.
Those are the real challenges, right?
Yes,
So
yes,
these
yes,
are
that's
these are
right.
the advanced troubleshooting things, right? To
Okay.
go over the
Mm-hmm.
logs immediately, understand, look at the 5 4 places and resolve that issue, or you do
Sure.
a DR switch and you fix it, you make the performance of the applications, you reduce 5xx call, make all 2xx call. Those kind of activities
Mm-hmm.
lies in the pursuit of SRE engineer. So think about it.
Yeah.
Non-production is a safe game.
Yeah, they
Non-production is
know,
a
like, yeah,
no
yeah,
pressure as such,
no
right?
pressure.
Okay,
Yeah, yeah,
developer is building some regression. Okay, some new code has gone into. Let's test regression performance suit, and okay, looks good. Just report it. It's a very safe game, right? It's a
yeah, yeah,
coming to, if you compare about production challenges, they're going to be immense. So it's
yeah.
like extended thing of a troubleshooting mindset. What performance engineers do on daily basis.
Okay, okay, okay. And if you can like put in the message, like any good books, like no few good books which we can read, right, while
Okay,
doing this course,
it's
right?
a Google book, SRE Google
Yeah,
book.
on
Okay,
Google I saw like two, three books, but those are mostly theoretical,
no,
right? I
this
didn't. Okay,
No,
which one
yeah,
is that?
you will not get any practical. So you
Right,
can
right. That's what
join.
I
You
saw
can
on the Google site, right?
No, you would not
SRE.google.
get it.
Yeah,
This
yeah.
this Isari word has come from Google, and this is a book.
Mm-hmm.
So you
Mm-hmm.
can go over this
Yeah,
book, but there is
yeah.
no hands-on. There you will not find
Correct,
only the
correct.
person who has done it can tell you about all those things.
Yeah, okay, okay. And there is no other
Yeah.
book beyond this, right? That these
No,
books
no,
I have
no.
looked at. Yeah, yeah. Okay,
Yeah.
okay. Sounds good. Thank
Okay.
you so much for
Sure,
explaining
sure,
everything, Rasan.
sure. Thank you so much, everybody.